Okay, this is DPRG's Robot Builders Night Out, November 8th, 2022. Gosh, 4 days to our Robo Columbus competition on Saturday. So 4 days, guys. And
3 days?
Oh, 3 days. You're right. I guess you don't count Saturday. So 3 days to go. So it'll be real interesting to see how it happens. Now, like I say, we encourage people, even if their robot, kind of like moves a few feet and blows up, to definitely come and put it out there. I've had worse. I've had a robot that didn't move off the line. So you can't get any worse than that, guys. So go ahead, bring it out. We get to talk about your robot. Boy, that's crappy. No. Have fun and do what? Get 1 point, and you get this year's Robo Columbus mug. Okay, which is a good one. It is really nice, and if you want it, you can go to the website and take a look at it. It's a limited edition. It will only be for this year. So if you don't get it, you don't get it. There'll be a new design next year. All right. So I guess the first question is Q. Who wants to stand up? Okay. I see Scott. Who else? I saw somebody. Paul. I thought, is it you, Michael? I heard a name. Okay, Michael. Let's see. Anybody else? Okay, then I'll give an update on mine too, since most of these people are going to be there. Okay, Scott, you ready? Let me make you big here. Okay.
Well, I wanted to clarify a point. Last year, the start area, the ring that you had marked, and the home cone were in different locations.
The home cone. No, the home cone was surrounded by a 10-foot circle, but the start line was next to the 10-foot circle. Is that what?
But they weren't typically in the past, and the way mine is set up is the location it started from.
Oh, okay.
Is it your intent to have the same setup this year?
Probably, but if you want to start at the cone, Scott, that's fine. That's not an issue. It's just
I
that
just wanted to clarify.
it depends on
over the cone or have it back up to the cone.
No. You have to go.
In front of the cone.
He has to. You can
going to do that.
You can put it in front of the cone. We can put the line in front of the cone. That's fine. That's not a. The only reason we did that last year was because that's the way we laid it out. There wasn't any rule-wise. I believe you are supposed to start at the other cone, the first cone.
I think the rules are kind of vague there, but
Yeah.
I just was curious of if it was going to be that way, then I'll have to set something else up. But I'm being a little over optimistic that I would actually be able to get back to the home spot.
Yeah.
Which right now is a fantasy for me.
Yeah.
This year anyway. But I just wanted to clarify that because that kind of makes it different of where you go back to. Because I normally would just go back to the same GPS location. Because if I remember right, in the past there was just a circle that you started in. As long as you came back to that circle, then you completed the course. There wasn't really a cone there that you had to find.
No, there was a cone. There's a cone at home. There's a cone that's, quote, I forget what the name of it, but it's the easy cone. And then there's one that's off, that's the hard cone. So yeah. So you go from the home cone to the other one, back to the challenge, and then back home. Okay, so it's
I mean, I could make that work.
Yeah.
maybe.
Yeah.
If I can
So
get the rest of the robot to work, that should be trivial.
yeah, yeah. Well, I'll talk my turn when I get a turn. So you'll be there.
There's at least a 90% chance, yeah.
Okay. Okay.
I'll have at least one robot that'll do something.
Okay. Great. Okay. So anything else, Scott?
No.
Okay.
I had a
All right.
question. Are I'm probably jumping out of the queue here.
No,
Or in the
no.
queue.
If you're talking to
Um,
Scott, you're fine.
oh, oh, talking to Scott? No, I was just had a general question. Are the coordinates of the cones in decimal degrees?
Yes.
Degrees?
Well, no,
decimal
no, no,
degrees,
no. Wait a minute.
Degrees and decimal minutes?
You may have to. You may have to
Degrees and minutes.
convert to. The ideal would be that it's in decimal degrees.
Decimal
Or-
degrees, yeah.
But unfortunately, when we lay out the course, I use an older Garmin GPS, and the Garmin GPS gives it in minutes and seconds. So you have to
For it.
convert it. So you may get it in minutes and seconds, but whoever
Okay.
converts it, we'll share those numbers around.
Okay. Yeah, Steve, Kareem asked me to ask Steve what it was, and I think he said degrees. I don't remember which one it was, but it wasn't the one that he said it was. So there was a little bit of delay
Yeah.
there.
Well, like I say, that's like I say, the Garmin puts it out in minutes and seconds.
Yeah.
So, but that's not hard to convert.
No.
What I put into my program is always degree decimals. So that's
Yeah.
and
Decimal degree.
if we yeah, there may be even a way to use your phone. I'm sure you can. I know you can take a point, but I don't know if you can take the point that you're standing at. I don't know.
Okay.
I don't know if you can do that, but you might be able to. So you'll have three reasonably accurate coordinates. You got to remember that the coordinates are allowed to be 30 feet from what you got, because that's just normal GPS tolerances.
30
So,
feet?
yeah. Well, the idea is that think of a golf course, okay? In a golf course, every morning a guy goes around and he sets the pins. So they're in the green, but you don't know where in the green they are until the day you play the course, and it's kind of like that idea. So, because if we got somebody who was really, really a super stickler and said, "Oh well, mine was 67423, and you said it was 6742," that's the reason I wrote. No, that's not. That's not going to fly. The fact that the coordinates are taken with an ordinary GPS, and then we put a cone sign, usually right there, and then we take, if Steve will allow us, we take 10-foot piece of string, and we go around and mark a circle around the course with, spray paint. Ideally spray paint that's washable. I don't know that's like what the construction people use. And so that makes it a lot easier to judge what's going on. That way you don't have to guess, well, did he pass by 10 feet? No, because the rules allow you to drive by the cone, never touch it, never stop, and that gives you 1 point.
Oh, just as long as you're within 10 feet.
As long as you pass by the cone 10 feet. All right. Now, if you stop inside the 10 feet, you get a second point. But if you touch the cone and stop, you get a third point. If you hit the cone and keep going, you don't get a point for the stopping at the cone. Okay? So, but But if you manage to hit the cone and then say you bounced off or you went somewhere and then stopped in 10 feet, you still wouldn't get the cone touch point because it's the at the cone for 5 seconds. Touch, So if
You got to touch it for 5 seconds? I thought you just had to touch it.
No, you have to touch it for 5 seconds. You have to you touch it and stop.
So you have to physically touch the cone. So if you're 2 inches away for 5 seconds,
There is a black base around the bottom of the cone. That's considered part of the cone. So if you touch the base of anything that's on, when you pick up the cone, anything that's on the cone is the cone. It's not just the red part that's up. There's a little base of a couple inches around the bottom. So yeah, I mean, if you went around and got stopped for 5 seconds, 1 inch from the cone, we would all cry with you. No, I mean,
Okay, I hate to interrupt people, but can I get a gold star? See this thing that moves on its own? It's autonomous.
well, we'll put you in the queue, Harold.
Oh, he likes you. Wait a minute, I want to put this picture.
Yeah.
Okay, I'm sorry to interrupt, but I interrupted. I'm not sorry.
That's what I figured.
I'm-
Okay. All right. So
Sorry.
next one was Paul. Paul, you got
So this is unrelated to Roborama.
Robo
but
Columbus.
It's a new discovery.
Oh, great.
I've been traipsing around the South Pacific for the last month, and 3 weeks of it on a sailboat, going from New Caledonia to Australia. And my buddy, whose boat I was on, yeah, it was awesome. But my buddy whose boat it was on is a real true geek, and so we get on real well. And he introduced me to this new widget, which I would like to show and say a little bit about because it's pretty cool. It's an M5 Stick
Stack?
C,
Yeah.
and
Whoa,
the
whoa.
button,
Can you say that? Can you say that again?
M5 Stick C, produced by a company called M5 Stack. Are you guys all familiar with it? Looks like Ray's familiar with it, but others maybe not. Anyway,
No.
It's got some power. It's got a power button here, which I just press and hold to power it on. Because I wrote a little application for it, and it comes on, and you can got a little LCD that you can't read here, but it's basically trying to connect to the boat Wi-Fi at the moment. But the application isn't terribly relevant. It was connecting to an MQTT server and also to a socket. So it's got an ESP32 in it, but so it's got Bluetooth and Wi-Fi, and it can be programmed using the Arduino development system. But what's kind of interesting about it for kind of robotics applications, it's got a I2C, like what are those quick connect, SparkFun quick kinds of equivalent buses on the end of it. Also USB-C, which you can use for programming it, and serial output using the Arduino development environment. And a couple buttons. There's a big button on the front here and a smaller button on the other side. Anyway, so it sort of is smaller, but has some perhaps possible similarities in use to Ray's little widget that he uses for looking at his robot data. And yeah, it's much smaller screen, obviously. But I thought it's kind of cool for, Arduino kind of things. It's got a some I/O pins. Let's see if we can get that to show on the end here. Some 0.1 inch. You can sort of almost see some 0.1 inch pitch female header there with 3 GPIOs brought out, and then power and ground and 3.3 volts and battery. So got all that kind of capability. And it's interesting because there seems to be a fairly okay, now how do I forgot how I grant permissions to share windows. Done. I was going to share and
Well, go ahead. The one that looks like a box with an up arrow
oh,
down at the
Here we go.
bottom.
here we go. Connection secure.
If not, I can share. I found a website that y'all might be interested in on that product. So let me share, Paul. And you can talk about it. So I can find the button. There we are.
He may beat you to it.
Yeah, he might. Considering I got too many windows open, so I'm having to figure out which
Are you
one.
guys
So they can go
seeing,
first.
yeah, okay, you're seeing this. So so this is their website, and they've got several versions of this thing. This version I'm showing here is are you guys seeing it?
Yes.
Yep.
Is a 5 centimeter by 5 centimeter stackable thing. What I just showed here was the stick series that has a little box with the I2C coming out of it, going to different kinds of devices. And then there's another series called the Atom series that I really don't know anything about it, but they're all basically Arduino compatible with Wi-Fi, and so I thought what was pretty neat about it was that it's like super easy to share with the. Let's see, okay, how do I do this? Why am I not seeing this? Am I still there?
Yeah, you're still here. But you have
Not
to.
presenting one.
You're
You're
not
not
presenting.
Okay. My sharing screen kind of froze.
Okay.
Well, okay. So anyway, just to say, I was going to share a little sketch, Arduino sketch, but just to show the simplicity of programming the thing. But I'll probably have to break off and rejoin. But anyway, suffice it to say that it supports the typical Arduino serial.begin, and then it's got like m5.lcd.set rotation and .set text color and .set cursor, so you can, and then it supports the Arduino Wi-Fi interface. So it has a pretty neat bunch of stuff for getting it hooked up to networky kinds of stacks like MQTT. So anyway, that was all I had was.
And Paul, I just put up for you the GitHub I found for it. So FYI, as you can see here.
Paul, can you put the link of the site you were showing us with all their products?
Yeah, sure. So I'm going to have to drop off, I think, and rejoin because my computer froze.
So Paul, it does look interesting because, as I said, there's a GitHub for it, and it's you can seemingly do Python and stuff like that.
Yeah, it supports like MicroPython and one other development environment.
Andrea, looks like, I don't know what UI flow is, but anyway, there's a UI flow seemingly. So
yeah, there's another one that's similar to that. It's the WIO terminal. It's based on the SAMD 51. It's got a little 240 by 320 LCD, not touchscreen, no. It does have a little 5-way button here. You can, up, down, left, right, and select. 3 buttons on the top. It's got, the connectors for, I think these are actually Grove connectors, but it's similar to, the quick connector, little different form factor, and they make adapters between the two. It's got an SD card slot on the side. You can plug it on a Raspberry Pi. This is a 40-pin 2x20 connector, so you could use it as a display for a Raspberry Pi. And the reason why I got this one and this one, I think this one was like 36. I got this one for 36 on sale. Usually they're like 39, but the M5 stack stuff was just more expensive.
So, hey, can you go ahead and put a link into that, Ray? What you said?
Sure.
I didn't get that one.
Oh, okay, sure. It's actually Seed Studios, I guess.
Oh yeah, they're actually really. I think they're out of Hong Kong, aren't they?
I think so. Yeah.
Yeah, I've got a lot of their stuff. They're good. They're the ones that did the Maxi bit.
Yeah. Yep. Yeah, their stuff seems, I thought, underpriced for what you get. I mean,
Oh, yeah. The problem is there is a lot of shipping with it when you try to actually get it sent to you.
Yeah. I got actually this. This is the WT32-SC01 model. Got it from Banggood, and it was on sale on Banggood. So, but that's got a 420 by 480 by 320 touchscreen on it. Really nice capacitive touch. It's got, I think, actually 2 40-pin connectors at different locations. It's based on the ESP32. So, and I'm just using the ESP32 now protocol to send, kind of operational / debug information to it. And so I can just, look at it and not have to chase the robot.
Mm-hmm. Well, after the competition, and probably a couple weeks later, we probably need to look for another another project. And the idea of trying to replicate your handheld thing, or if you want to go version 2, that might make a really nice and interesting project.
Or presentation, you mean, or
a presentation to get started, but maybe actually have some more club members actually make some. So let me. Can you put those links? Oh, wait a minute. You have Seed Weed Terminal. Okay, I got it.
Yeah, it's the Weed Terminal. If you just go to the seedstudio.com, and I'm not certain how that. I could just try it here. E's. Yeah, it is 3 E's. Okay, so that's the link to Seed Studio, and it's either look for the WIO terminal or the WT32-SC01.
This is the one you would recommend.
Either one. The Wii terminal it's SAMD 51 based, The other one is ESP32 based. This one does have Wi-Fi, but I can't use ESP32 now with that. You have to have two ESP32s to do that with,
Mm-hmm.
because it's kind of like a proprietary protocol.
Mm-hmm.
So that's why I've used the other one.
Mm-hmm.
I don't really use the touchscreen for anything, but you could do with ESP now. You can do one-way transmits. You can do two-way between two devices. You can have one transmitter, multiple receivers. You can have multiple transmitters and one receiver.
Mm-hmm.
So there's all kinds of different ways to configure it. Those are about the cheapest devices that I've seen
Okay.
for that.
Yeah.
But I think M5 Stack, though, they've got every peripheral you think you can.
And it looks like, you can do a lot with that. Let me show you that page I found on it.
Yeah, there's tons of stuff for that. Whereas these are kind of standalone. I think you can get a battery pack for the Wii terminal, but it's got a USB-C plug on the bottom.
Because, amongst other things, it looks like they have a balancing kit robot for it. A one with claws on the front. I have this one I have no clue what that is. It looks like
a
no
walker.
board walker board type thing. So they definitely, and it looks like they're not overly pricey either. So the price looks very good, actually.
Mm-hmm. Okay.
And also there's an instructable too. So let me pop that in.
Well, let me ask Paul. Was the screen that you showed kind of like the maximum size screen, or is that just the one you happen to have?
It's a 1 point something size screen.
Yeah.
It's the size screen that comes on the M5 stick, which is, one of their product types. I don't know. I'm not familiar with their whole product range or with the like what you can get on the. Looks like they got a larger screen on the stack, on the M5 stack product that's 5 by 5 centimeters. So I'm afraid I can't say much about.
So you don't
have in-depth knowledge of it. I just thought it was.
It's really cool.
Little thumb-sized computer that can do Arduino with a couple of IOs and a couple of buttons and some Wi-Fi and Bluetooth. So that was just really cool.
Yeah, it's more watch size, or at least it looked like it
watch
was.
size. Because it says something here about
it's a big old watch.
0.96 inch LCD.
Yeah, 80 by 60 color.
Yeah.
On their web page, they actually show a wristband so you can wear it like a watch.
Yeah. Okay. I was just saying. I got to admit, I never heard of the M5 Stick C. So that's new to me.
On Struttables, how to program it.
Yeah, me neither. And my buddy just ordered 3 of them because he thought looked really cool. And then when I got aboard, he said, how about you hook this up to the boat Wi-Fi and pull some NEMA records down off of the AIS server and display the time and the current wind direction and wind speed. And so I did that, and it turned out to be remarkably easy. Yeah. And so it was like, oh, that's pretty cool.
Mm-hmm.
Wait a minute, this sailboat you were on has Wi-Fi?
Oh, let me tell you, David, it has everything. This is a 58-foot Beneteau with separate with a generator and a water maker and every air conditioning and every mod con that you can imagine. I mean, it's just a gorgeous boat, fully equipped for blue water cruising.
Okay, I just looked up 58-foot Beneteau, and wow.
Yeah, yeah. It's the one I sailed from Mexico to the Marquesas on in 2018, and then from New Zealand to Fiji on in the beginning of this year in May. And my buddy's been touring around the South Pacific, and every now and then on a long passage he appreciates an extra hand to like help on the night watch. And so I do the 4 a.m. till 7 a.m. watch, and us radar and AIS display on the chart plotter. So every 20 minutes you like turn the radar on and scan around for anything, and look at the AIS and make sure
Pirates.
there aren't any. So AIS is a VHF based protocol where all ships are required to broadcast their location. That's what the Russian oligarchs' boats have been turning off, while they're transiting to places where they can't get boarded or arrested.
Safe harbor.
Yeah, right.
Hide their boats.
Yeah, exactly.
What I'm really hearing is that I need to get some better buddies. That's what I'm doing.
Yeah, and so it's kind of neat, kind of spooky, kind of scary when you see another boat coming onto the chart plotter. It only has a range of about maybe 20 miles, but you see a boat like coming towards you or stationary in your path, and you're like, "Ooh, okay." And
Pirates of the Caribbean, huh?
well, yeah. And one time, as we were heading in towards Fiji, I witnessed AIS being used for collision avoidance. So my buddy, the captain, was up on deck, and we were looking at it, and we saw a ferry come out of the harbor entrance and turn directly towards us, and he was on on a path for collision. And so then my buddy steered upwind a little bit, and he steered upwind a little bit. So we were both like still on a path for collision. And then my buddy said, "Okay, so we're gonna." And I was saying, "Well, do you want to call him on the VHF?" And you say, "No, this is how you do it. How captains do it. They look at what each other is doing." So he headed downwind a bit, and the other guy held his course. And so then we were on non-converging courses, and he passed a mile away from us. But it's like pretty interesting seeing that collision avoidance like actually in play.
Mm-hmm.
So you're saying it's kind of like what happens when you walk down the New York City street and you're aiming for somebody and you both go the same direction?
Exactly.
Yeah, okay.
That's exactly what it's like.
This may be something that our mobile robots eventually need to know how to do. And if you have the data, the calculation is actually pretty simple. As memory serves, if the incoming ship is maintaining the same bearing each time you look at it, it's going to hit you. But if the bearing changes each time you look at it, you're okay.
Yes.
So the hard part there is the bearing. That is, you got to take multiple readings to know which way this guy's going.
Yes.
Did I do that right, Paul?
That's exactly right, David. And you can approximate that behavior when you're doing coastal cruising. If you're around some islands, you look at where a boat is relative to an island in the distance, and if he's moving left, then he's going to go left of you. If he's moving right, he's going to go right of you. And if he's staying in the same spot relative to the island in the distance, then you're going to collide.
Yeah, I think pilots do that with a little grease pencil. They put a mark on the windshield and say, "Okay, if that doesn't move, he's going to end up on your windshield."
I've seen that on Deadliest Catch.
But the AIS software on the plotter gives you even more. It tells you closest point of approach and time to closest point of approach. So that's real helpful, like when you're out in open ocean at night, and if he's going to pass a couple miles away from you, then you're fine. You just watch him and keep an eye on the situation. But if it's closer than a couple of miles, then you take some evasive action.
Well, I just wanted to say, if you wear your M5 stick on your wrist, they're chick magnets. They just love them. Like this one here. So,
Excellent.
see, I got mine right here. In my
It looks like you have some kind of medical device that's monitoring your failing heart or something.
That's right. Yeah. Keep it going. Kick start it every so often.
A real chick magnet.
Okay. All right. So I think the next person was Michael. Michael, you still there? I can't see you.
Yeah,
Oh, there you are. Okay.
I just had my mic off. I know y'all been, if y'all remember, I've been messing with trying to messing with code to get my robot to run straight, and I had some off of SparkFun. I got a straight line off of SparkFun, but the problem with that code was it didn't let you adjust the motors individually. It's in the code, it had it all tied together. I didn't understand it. So anyway, I found some code example off of a DF robot website. Yeah, I'm sure a lot of y'all are just way past this, but for me, but it was like an example code of real short for one motor, and I took it and I'm building on it, and it's working real good for me. And it's PID control. So I've been looking at PID control, not just a P. And I'm kind of maybe show you this, just a hair. I'm not going to go in real deep with it. I'll present. That's the entire screen. Wish you'd remember this. Okay, there we go. All right. So anyway, on there, y'all see that?
It's pretty hard, Michael, to really see it. Okay, but that's the encoder motor.
That's that cheap motor I've been playing with.
That's the one with the encoder on it.
Huh?
That's the one with the encoder on it.
Yeah, that's the one that you've actually
Okay.
have some of those.
Yeah.
But down here they've got the PID, a sample code of PID control.
Okay.
Use the Arduino PID library, but it's real simple. And I quit trying to. I'm gonna unpresent here. Stop presenting. I quit trying to kind of understand everything, So I know how to manipulate it. So I've got two motors running on it now. Got it doing a U-turn. But I got it running a straight line. And what I like about that example code is I can mess with those motors independently if I need to.
Mm-hmm.
So I have control over that. So I just wanted to share that. And I got one other thing I was wanting to share was, has anybody messed with that new Arduino IDE? I know Harold didn't, but the new one, they put it out, it's ready for prime time. And it looks like it's got some potential. It's got some bells and whistles on it that the old one didn't have. So, has anybody else?
I'm still not real happy with it because my Visual Studio Code, which is what that whole thing is based on something called Electron. Doesn't do some of the things, but I will tell you this: it's fast. As far as you hit the compile button, and compared to the old IDE, it's like somebody hit the super turbo button, and we got the tortoise still working on the old IDE. It's comparative. It's just really fast.
Yeah, it's just a little. It's a little step up better than what it was, but it's got some things on it that the old one didn't have, as far as being able to navigate through the code, where the old one didn't have anything. You just had to scroll through it and find it. Maybe do a search, but other than that, pretty good.
So that's the
Anyway.
online version you're talking about?
No, it's a downloadable.
Oh, it is.
Yeah, it's 2.0, 2. Something that just went to GA about a month or so ago.
Yeah.
Okay.
So
That's right.
anyway, that code that PID code that I found, I'm real happy with it because I can manipulate it and I can take it and use it for my projects now, and I won't be frustrated trying to at least start off in a straight line when I try to do other activities with it. So, all right, that's about all I got.
Were you going for a gold star there, Mike? Were you going to show us something?
No, I don't have it. No, I don't have it on the floor.
Okay. All right.
But I just want to let you know that code's out there for anybody who wants to start off, and it's real easy. I'm through hunting now. I don't have to Google anymore. So.
Oh, that's a lie. You still have to.
Well, at least for that, I don't have to Google that.
Well, that's,
So anyway, maybe one little question before I got off? When whoever's presenting that module that Paul had, they had that Vizino graphic IDE, graphical IDEs. Anybody ever mess with that?
No.
No, you're talking about they have like widgets and stuff like that. Like you can have like
It's GUI. It's GUI with
yeah.
It's almost like one of them little Scratch or something kind of program that kids have.
Yeah, I think it's I thought you were talking about some of them have like graphics packages where you can and the WT32SCO1 has that where you can just say I want a meter here in the corner and
Right.
a simple digital display here and some graphic in behind it and all that kind of stuff. But I don't think that's what you're talking about, right?
No, it's a graphical interface here. I can pull it up real quick.
It's like programming with blocks, right? Blocks interlock and
Sort of, but the screen that whoever was presenting that module that Paul had, that program was on that screen, and I've messed with it a little bit.
yeah. Do they call that like
I'll
visual
show it here.
programming?
Hold on. I'll show it here, right here.
Oh, no, that was, you're talking about John showed their website and they had.
Nobody's ever seen that before?
Well, it looks like the old National Instruments version. They used to do stuff like that.
Yeah.
Oh, did they?
yeah, Node Red does something like that too. I wonder if they're.
Yeah. If you have, I don't know, I just, that to me, I guess I'm starting to get like, how old timers are, they're always saying, well, I'm using VI. And I've always thought, who in the heck would use VI, Well, besides Dave. Who would use VI when they have all these IDEs that are so cool,
I said the same thing.
And now I'm, getting one like that where when somebody shows me one of these block programs, I just say, I'd much rather do it in code than make a block like that.
Oh, yeah. I was just wondering if anybody had messed with it because, see, I'm still so young in this hobby that I'm not stuck in my ways yet. I'm still looking around and stuff. So.
You just wait.
I'm not saying I ain't headed there, but
Doug, my IDE is called Linux.
It's called what?
My IDE is called Linux.
Mm-hmm.
I'm running Linux right now.
That's right. You guys still can't figure out how to get rid of the terminal yet. You have to. You got to have at least 6 terminals up so that you can actually do anything. So.
But that Visio or whatever is Windows only anyway. I'd have to put it in wine or something like that.
Yeah.
No, 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 no. Visual Studio Code builds all the stuff. Visual Studio, which we're not really using, is pretty much Windows only. But Visual Studio Code, we're on Windows, Mac, Linux.
Yeah,
Pretty much
I had
everywhere.
that. Yeah, Doug, when Doug did that presentation, I just hadn't got to that point where I needed that yet. I'm still messing around in, you know, I haven't gotten to where I'm making my own libraries and stuff like that yet. So I know one day I will.
Yeah. Well, in like most of the robot projects, or at least once you get a little bit beyond, they become so much easier if you can compartmentalize the different functions. So, like your motor functions are all in a pile, and you can reuse them on your next bit of code without any changes. You know, if you write your code so that it doesn't depend on anything, you know, it's just you can use the functions. They tend to be a little bloated, but they will, you know, the transport, being able to transport them from program to program is such an advantage, and it's really nice.
I'm getting a collection started.
Yeah.
And so, and like this PID code I was showing you tonight, it's going to be in my repertoire.
Yeah.
You know. So.
I think it's Mike. It's like the the boating experience. You know, you start out as a swab, and then you get promoted to baiter, and then if you become really good at that, you become a masturbator. So
it's
Oh, I knew that.
I should have. I knew it was headed somewhere.
What's that?
I knew it was headed somewhere. So I have I'm a crappie fisherman, and I usually fish by myself, so I really have no other choice, you know, but to bait my own hook. So I've become very good at it.
Yeah. Okay. All right. So I think it's time for me to do my little update. Well, first of all, I want to thank David for his suggestion last week. You know, it did take me. It has been work. I did get wrapped around the axle, but it's such a better approach. So right now, my robot is what it does is the Oak Delight is always looking for the cone. All right, and when it finds the cone, it basically takes over the steering, and the servo will turn. So what's actually happening is when it first sees it, the OD light will point at the cone, but it's also tied to the steering servo, because both of them are on servos. So if one of them points, you can make the other one point without any problem. It just follows it. So that I'm doing that. My biggest problem that I've run into and I can't seem to get over is when I find the cone, it does pretty good the first time. But if I jerk the cone and put it somewhere else, when it tries to go find it with its sweeping, it sweeps. It stops the robot and sweeps to find the cone. Well, sometimes it just locks right in and everything's hunky-dory. But sometimes it just starts whiplashing. And I know that that's something that in my code that I haven't conquered yet. So I've got to figure out where the bug is. It's a bug, and I've got to find the bug. And, it got so frustrating that how these projects work. So you start off, you got very nice, neat code. And then you start saying, well, shit.
It's an undocumented feature.
Yeah, well, no, but so maybe, but you say, well, damn, maybe it's this. So you yank this little variable a little bit, and now it's a little better. So I'm going to leave that there, and then you go over here and you yank something else, and before you know it, you're looking at the code and you say, what did I do again? I got stuff over here turned, or this over here changed, and that over here changed, and so now so I'm struggling to get through this, but I think so. In that, in the rain, I didn't get my time out on the field. So, and we got, what was it, Gray? 3 days or 2 days? 3
Three
days.
working days. Yeah.
3 working
Wednesday,
days.
Thursday,
so,
Friday.
So I'm not, I'm afraid I'm going to be like Scott. Now I'm not sure if it'll go all the way around, but I should be able to get my mug this year if it doesn't stop at the line and die. We'll have to
We
figure
all
out
have to do one better than bringing a basket full of parts.
Doug, my experience with that similar technique is that what would happen is the camera's basically rotating back and forth, and as I mentioned last week, that's sort of like giving your camera a wider field of view.
Mm-hmm.
And then when it locks on the cone, it's usually pointed off center somewhere.
Yeah.
Okay.
It always is, because it's going to come in from the edge.
Yeah. And so what happens then is the servo on the camera is trying to keep the cone in the center of the image.
Yeah.
And the servo driving, or the steering driving the robot, which is being driven by the same signal. So if we're looking to the left and we're locked on the cone, then the robot will steer to the left. And what that does is center the camera back on the robot. Is that what you're seeing? That is, as the robot rotates left.
Well, since it's up on a stand, I can't see that. So right now my servo is my steering is really disconnected from the top. I can watch the wheels turn, but I haven't really. That's a good point. I really haven't thought about, well, maybe this is a non-problem if it was actually running on the ground. Do you know what I'm saying?
Well, that's what I was suggesting. I actually found that I needed 3 modes. The first mode is when the robot's just steering by GPS and the camera's just scanning.
Yeah.
And the second mode is the camera has locked onto the cone, and so basically it's steering the robot.
Mm-hmm.
The third step was when the camera's actually lined up with the, it's rotated now so that the cone is directly in front of the robot.
Mm-hmm.
Then I stopped the servo that's driving the camera. I just lock it in place.
Mm-hmm.
So the last few feet or yards is only steered. You're still trying to keep the image in the center of the camera, but you're not doing it by moving the servo. You're doing it by steering the vehicle. And the reason I needed that third step was because as I got close to the cone, it would sometimes start to oscillate again, trying to keep it in this.
Yeah, well.
So I just, once I'm locked onto the cone and the camera is centered over the robot, I lock the camera in place. I don't allow it to move anymore.
Okay, that's something I gotta take a look at, because that might actually be a good advantage.
But I think the problem you're describing might actually not exist when you're out there moving.
So what my strategy had been was this: when it loses, because it occasionally will lose the cone, because it's bouncing. All right. And so what I was trying to do is says, okay, you're heading towards the cone, you bounce or you drift off. Then what you do is you stop and then sweep and relock. Okay, that was what I was going to do, and then go from there. But once you got it locked, you should be able to not. I see what you're saying. Well, in my code, it shouldn't move. If it's locked, it shouldn't move the servo. Okay. Well, I guess it would. I'll have to think about this, but that might be part of my problem, David. And I'm like I say, the last couple of days I've just been wrapped around the axle and just kind of beating myself on the ground. So I'm hoping I can get through this.
I've got a similar problem. I really wanted to use the OpenMV H7 with a serial interface, but there's something weird going on with the ESP32, and about every second or so, it just throws out some random value. It doesn't actually say what the centroid of the X of the blob is. So it, it's like throws it actually starts to rotate like it lost, um, you know, the blob tracking, or there's no cone out there, or it wasn't within the, well, this is LAB parameters, but anyway, so yeah, it'll go along, it'll start heading towards the cone, and it'll do this little twitch, and then because it starts to rotate, and then it'll move along for about another second. And I've looked at, I've tried to, print out the variables from the OpenMV H7. I've tried to do it, to see what the ESP32 is received, and it's still there. So I actually had it working with the Pixie Cam, not my preferred camera, but I think in the next couple days here, if I can't figure out what the little twitch is with the OpenMV H7, I'm just going to use the Pixie Cam.
Well, Ray, what you do when that happens in the competition is you just call out, look how skillfully it avoided the cone.
Oh, yeah. Yeah.
Perfect.
It's like a little twitch. It'll be cruising along, twitch, and then come back. And
Doug had one last week where it got within maybe a foot of the cone and then skillfully avoided it.
Yeah.
Skillfully avoided it.
Yeah.
Yeah.
So, David, did I understand your initial naive implementation to be you found the blob in the camera, you then could rotate the camera to center the blob in the image, and then the robot would rotate to hopefully make the camera point straight ahead? Was that pretty much how the naive implementation?
Yeah, basically, once the camera sends out a signal that says I've locked onto the cone, then you're no longer steering according to the GPS coordinates, but rather steering according to the offset of the camera.
Yeah.
And that sort of automatically centers the camera on the robot body. But once it was centered, as I was approaching quite close, it would sometimes move around trying to keep it accurately centered, and that would cause the robot to lose its center. So when I get to that third stage where the robot body and the camera have now rotated so they're lined up, I shut off the function that can steer the camera separately and still try to keep the cone centered in the image, but by driving the robot's body rather than by steering it.
Right. And
I just had to do that for the last few feet. I actually don't remember why.
Yeah, and as you were describing that, what came to mind was back to engineering school control systems theory, and every control system, whether they're like two stacked control systems, if they're in series, it still can be viewed as one control system, has a frequency and a phase shift. And when you get when you put an impulse into it, the output responds with some phase shift. Like if you feed a sine wave in, you get a sine wave out, but it's phase shifted. When the phase shift approaches 180 degrees, it will always oscillate. And it just occurred to me that as you were describing that you've got a time delay in the camera response on top of the robot, and then time delay in the robot's steering response that could well approach 180 degrees phase shift, which is guaranteed to make it oscillate.
I bet that's what's happening, that it's basically a latency introducing, removing the ability to lock in. And by turning off the camera servo, you drop one step out of that latency.
Yeah.
So now you're controlling the camera directly from the robot motors rather than from its servo. I bet you're exactly right. That makes total sense. So now I do know why I did it. Thank you.
Kareem, remember where Steve lives? If you don't, just send me a message, okay?
I do remember, but I can't make it there.
Oh.
I thought I said that previously. We've got
I'm sorry. I thought you were going.
We've got to meet this Saturday.
Yeah. You did.
Yeah.
You did. I remember it now.
Yeah.
Doug, you might send me the address.
Okay. Well,
I
David, just because remember, I'm really distracted right now.
I'll send you a note.
You send me a note, please. Anybody who wants Steve's address, just send me a note and I'll send them the address. Okay.
It's not on the website.
No, it won't be because Steve wasn't real excited about having his personal address published on the website.
Everywhere.
Yeah, so that's what I'm saying is if you want to join, let me know. I believe similar information is on the website. It'll tell you to send an email to secretary.dprg, which is me. So.
Okay. I was going to try to make it over there.
Oh yeah, well, Mike, I think we'd love to have
You
you.
know, moral support.
Yeah.
I got a robot that
Oh, and remember, there's free food.
can run a straight line I can bring.
Hmm.
That's all it'll do. I got a robot that'll do a straight line I could bring in. But
Well, hey, if it can go 100 yards, you might get yourself a
Mug.
a mug.
oh, right. But yeah, I might do it.
Yeah. I can remember, I think it was the last time we were at the Nature Center in Dallas. A young gentleman basically glued his steering mechanism, and pointed it at the cone and let it rip. And he had some kind of bumper on it, and he drove straight. We didn't go 100 yards in those days. We probably were 50 feet, maybe 100 feet. I don't know. And he drove it. His robot, which was like an RC car, drove the 100 feet, hit the cone, the bumper activated, stopped, and he won.
I remember that. I remember that.
Yeah. So.
Well, my Rover last year, that's essentially all it could do was do that.
Yeah.
It came in at about 20 feet over 100 yards.
Yeah.
I figure that's pretty good. I mean, I'm sure I got lucky with the bounces and the rotations and all the unevenness, but I figured, what the hell?
Yeah.
Pretty good deal.
Yeah.
Doug, can I show a picture here, or am I out of order?
No, well, I was the end of the order that I had, so go ahead, and it's now on to free for all. So go ahead, David.
I'm going to free for all here, just in case anybody was curious. I know I was. Entire screen, allow. Did that do it?
Yep, that got it.
Okay, I want you to see the interior of this ship that Paul was on and how much he was roughing it.
Ooh. Looks horrible. Oh my God.
Paul, does that look anything like the one you were on?
Yep, it's just the same. It's just the same.
Paul, how many people were on the boat?
There were 4 of us.
So how many staterooms does it have?
3. So the owner had 1, and then there was me and my mate had 2. The other 2.
Well, if you look through that door, you can see there's a bed up there, and I believe that there are a couple more behind the stairs here. Isn't that correct?
That's correct. Yes. And if you click on the layout, it's like in the overview, it's 3rd one down on the left.
Is that it?
Yeah, that's it. So you can see up front in the V. So there's actually there's actually slaves' quarters. So there's actually another complete separate cabin accessed through a hatch in the bow. That's that bed shown and bathroom shown in the very pointy end of the boat.
Right here.
Yeah, but they kept the sails down there. So the owner's cabin is the double bed shown just behind that, and it's got its own bathroom, shower, just in the stateroom, and then behind that is the saloon, with the table and chairs around it, the captain's, that. You're actually looking across the boat, and what's at the far end is the navigator's station, and with the control panel up above it. And my buddy, being a a good gearhead, has developed extensive instrumentation for it. He's got a Linux PC, and he's tapped into the Bluetooth sensors, like he's got temperature sensors in the fridge telling him there's 3 fridges on this thing. You got the ice fridge for cocktails, and then and then the drinks fridge for beverages, and then the food fridge and freezer, and so you've got like temperature sensing for all of that, and then the amount of current being drawn by each, and when they run time, and amps out of the generator, and so forth. And so he's like graphing all that with what's that package called? Grafana. So there's a plotting package called Grafana that gives very nice graphical and indicator displays. So you can pull all of that up. So yeah, it's a nice boat.
I am so jealous.
Oh, I'm living the life, David.
Yeah, no question about it. You're also retired, isn't that the case?
Yeah, but I'm more fortunate than anyone ought to be. Let me just say that.
Yeah.
That's all I had, Doug.
Okay, cool. I guess anybody else have anything to say? Okay, Harold, let's hear it.
A couple of things. One, the kitty you saw was not my idea. That was the wife's. I lose every one of those battles pretty much. I was saying no, and somehow Lenny, spelled Lynny, is now shown up. The other thing that I really wanted to show though was I'm going to put this in the chat. So John, you sent me an Instructable last time, and that was, in fact, I can show it here. And I want to thank you for doing that, but I also want to tell you about what I found out. I have ordered parts to actually build this. I have printed a couple of the things that he's done, and it's it goes, and the source code's there. That's fine, and there's some good graphics there. But then I was looking at the source code, and I want to understand some things to move it into my BB Pi over here, right? And I'm looking at stuff. I like get down to the code again. Come on, where'd the code go? Got it. Come on, I know you're here. I'm zipping around like a crazy man. You'd think I'd have figured this out. Okay. I'm gonna zoom in here, which means I gotta zoom around again so people can see. So this is the code where it has in the loop to figure out to keep the thing balanced. And so I had a really hard time figuring out what the A10-2 and all that was going on and doing. And we found out a few things that we've discovered a few things, like what's the 0.97 and what's the 0.03. And we figured that's kind of a filtering thing going on there. And what we never found out was what is 131. Anybody got a clue? Well, I didn't either. So we got to looking around, and we doing stuff. If you look down here in the comments, nicely done. Can you go into a little more detail on how your complementary filter? How did you come up with your equation? Is it empirical? Thanks. Right? That's the question. I haven't devised the equation. I used one other big brains, whatever they came up with.
Yeah.
So 131 is like, I don't know, pop, wherever that pop came from. And so I did some more research. And the reason I did that more research is because I wanted to know. I didn't think I needed to know, but now I found out that, yes, I need to know this stuff, and I just can't use one of the big brains because my brain will not allow me to do that. And so what I found was I'm about to share a link out that I've already found it in the other place over here, so I can share the link very quickly, and I'm going to show it on the screen.
Yeah, and also put it in the web chat.
Yeah, that's exactly what I'm going to do. Web chat, here it comes. And this says at a certain place, and you might have to go around on it. Paste as plain text. said face, just plain text. This is a YouTube, and I'm going to show it up over here. This young man calls himself micro engineer. Like, I guess, let's turn yourself off. I initially had thought that no, we're not doing micro, and we're not doing anything because it looks a little bit janky. But he is building himself a flight controller for a drone. So he's using the 6050, which is arguably one of the most popular things ever. So I dismissed because I looked at the fella and he's like doing things. I'm like, okay, he's doing the same old things again. But what he does was, and you can see some of that stuff there, and like, oh, I recognize some of this. And he goes through and describes NED, navigation something downward framework is how you, it's a framework. What now?
Northeast down.
Northeast down. Yeah, there you go. See, I'm still learning all these terms. Goes into what all this is and how this framework works and all that sort of thing. And then he goes into describing a bunch of stuff. Describes what the IMU is going to be talking about. And then you're like, okay, that's cool, that's wonderful. And then he does a very wonderful thing right here, which he comes up and starts writing the equations with the transform matrices and the whole stuff on there, showing what it is. And if you follow down to it, he makes some stuff and shows that's matrix. He's doing matrix algebra basically. And so he can get these things. And as he goes on, there's some assumptions because we don't need to worry about the Z because we're not going down and we're not going up, or what we shouldn't be. If we are, we've got other problems, right? So you can zero some things out. And after he does some math for you, showing how the math actually turns all of that into 3 equations, and then works on those 3 equations and shows you how okay, that's one, and shows you how he works through those. He's talking the entire time, giving you instructions on how this works. And so we're used to seeing that. You got AY over AZ, gets you all that, gets you that, which is the tan of it. And if you go a little bit further, here we come with our A tan 2 and the AY over AZ, AY comma AZ kind of thing. And I'm like, oh, wow. That brings me to where he figured this out and where that all came from. I thought it was really good. I thought it was really good on there. And so I started playing with that. And now I've got some definite, when I started playing it, I don't have BB hooked up there to show you all off, but he's going on and showing him what he's got. And after looking at and doing some stuff, I was having a real hard time with figuring out what was going on with BB and getting angles and all that sort of stuff. I finally just got the IMU. I got a basic sketch going on here, and I'm now getting degrees out of this thing in some kind of decent form and fashion. I told you I would have never even thought. I was thinking about the way BB's laid out. X is away from me. Of course, Z is up, so I got to negative that thing. But Y is across. I'm like, okay, let's figure out this tilt thing. Throw that tilt thing in our PID loop to fire up some stuff, to do some fun things with. And I never would have thought that I needed to worry about the Z acceleration on that. And then once he showed me what's going on, he showed me because we are in a circle. And so that circle, that one acceleration that's going on, we also have another acceleration because we are in a circle that will have a component to it too. And I'm like, okay, now all that kind of makes sense. So if anybody's having a hard time figuring this out, this young man, I believe, did a really excellent video of showing this. The production value isn't the greatest in the world, but I thought he did a really good value. Really good, gave you a really good run for your money on the, bang for your buck sort of thing.
Harold, I got one question.
Okay.
Where's the 131?
Yeah, he hadn't shown the 131 at all. And so that's rotational velocity around the x-axis, and I haven't gotten to that part about. It's not in this video. He's got a series of videos that he's doing explaining this thing. And I'm like, we still know, I have no idea 131. And at this point in the whole design and development of BB here, where do we go? Whole design and development of BB here. I think we just throw that component completely out right now. Use that composite angle that we have there and see what I can throw at my pit loop and get out of it. I think maybe that's enough. I don't know, but we're going to give it a try. And I've got parts coming to build. Here we go. The instructable. I've got parts coming to build the instructable. I printed a couple of things out and that kind of stuff. So we're just going to build that other guy's instructable as is. We're not going to try to be fancy. We're not going to try to do anything else. And hopefully maybe next week, if all the wheels come in, yeah, the $10 pack of 10 wheels was $2 shipping if I didn't mind waiting. And if I wanted it this week, it was $40 shipping. So for $38, I think I'm going to wait.
Yeah.
You know, that's how that works. And we'll see whenever they come into. I'm going to build these things straight up. And of course, why would you print one when you could print two and have enough parts to build a second one? And I don't know what I'll do with the second one. Maybe give it away or have somebody auction off at bits on my channel or something. Don't really know. But we'll see how well that instructable actually comes out because we're just going to build it as spec and not get fancy and not try to do extra stuff with it. And I don't know where the 131 is. No idea. I suspect it's got something to do that I've been looking at this. I suspect that it's got something to do with the weight of this whole unit and gravity affect how the gravity affects it and how it rotates back and forth. I suspect that's what it's got to do with, but the guy can't tell me. He doesn't know, and we're just gonna have to figure something out.
Well, that kind of made me think of something. Is David still on? He mentioned that he prints in ABS. You know, this is a new technique for 3D printing, something that I have never heard of or seen. I came up with it myself. So take it, and I think what it is, it's an application of something else to 3D printing. You all know that if you print on the flat surface, you get a very, very strong part because it has peripherals and an interior, right? Is everybody with me? What I'm saying?
Yeah.
Okay.
Like a fill-in?
Yeah. So when you do that, here. So when you're flat and you're going around, that's going to be a very strong part. But now if you start going up there, make an L, okay, it's not going to be, those are going to be, all they are is individual layers. So you got a chance of layer shear. Everybody with me?
Yeah.
Okay. Well, there's a technology, and I'm not going to demonstrate it today, but I've just got 3 words for you, and one of them's plastic. It's a plastic welder stapler. So what it looks like is just got 2 prongs. It's just a heat gun, not a heat gun. It's just 2 electrodes, and you put in a stainless steel wire staple into it, and it's made for repairing like car bumpers and stuff. Okay.
Yeah, I've seen those things.
So they got a little usually like a lot of little S curves, or you can do one for a corner. So that would probably be, so if you had an L-shaped piece of 3D printing, you would take a corner stapler, which is kind of like shaped like that. You'd have to look at them, and you take them in there, and you just put it in the corner. And when you push the button, it heats up the staple, gets red hot, and you just embed it in the plastic. And then you what you do is you take your hand off the button and let it cool down. then you slip off of the stapler, and then you clip the stapler. So a technique for strengthening 3D prints that have that weak direction is to use a plastic welder staple and reinforce the place that's bad. Anyway, so
are you doing that in the course of the print or after the print is
after, this is after the print, so it's going to leave a scar on the print, okay? But what you do is you've embedded this piece of stainless steel wire into the piece,
Plastic, yeah.
and it's going to be strong. Now there's some things you can do to strengthen. I don't know if I've got one right here. Let me check.
See, do you have a picture of this thing? This tool?
Yeah. If you guys, I'll give it. Somebody else, go ahead and talk, and I'll go get it.
Okay. In case I have something for you, Harold, to add to the POW.
Add to the pile. Bring it on.
Okay. So let me click.
Is the 131? Is it like 42? The answer to life, the universe, and everything, or?
We have no idea. I was on. We were messing around with that, and there was another guy that doesn't normally come, but he's a control. He remembers doing this control theory and this kind of stuff, and he was racking his head. And I got a couple other smart people trying to figure out, doing math and figure out where all this stuff, and they just don't know.
Well, they might want to look at step 5. On this.
Hey, Harold, could you post the website where you found that 131?
Oh, certainly. Give me 1 second.
Thanks.
So this one talks about the math and that a little bit too. So you might want to look at this one. On step 5, they have the real discussion about it. Okay, and he has Brock's here. So, and the robot looks like that.
This is what the stapler, the heat gun looks like. And I shouldn't say heat gun because it doesn't get hot. All right, what you do? What you do?
So where'd you find that?
Well, plastic welding has been something that I've played with.
Oh.
And but I know, the other night I had a real nice set of kitchen scissors that have an ABS handle that broke, and they were useless because the handle was broke. I was able to stick a few of these staples into it, and it just like it was brand new. So, all right. So you have this, and then you just stick the staple. There's a little hole in the end. It helps if I can see. Okay, and there. Now that's a 90. I don't know if you can see that. Let's see if I can get it on the
like
wire.
an inside corner.
They call it a corner stapler, but they have an outside. So yes, this is an inside staple.
Yep.
All right, and you just when you push this button, it glows red hot. And so you have to be careful. You can push it right through your print if you're not careful. And you just just push it enough to embed the wire in. And they also have these little wavy ones. I think they have wide wavy ones and not so wide wavy ones. I'm going to show you a not so wide wavy one.
Doug, can you present so we can see that bigger?
Okay. Well, I don't. Okay. Thank you, Carl. All right. So it's hard to see them and I'm trying to get them against the wide, but all this one is a little wavy line. Do you see that?
Mm-hmm.
And so this would be like if you wanted to actually take two parts and weld them together, you would go across them with this. So you could actually build up 3D prints so that each piece was strong, and then attach the strong pieces using these wires. Now, remember, there's a lot of structural things in 3D printing design that you can do that'll make parts stronger than if they're just a wall. You know, a wall is never a good idea. So, I don't know if I have one.
Can you put a link to that?
Huh?
Can you put a link for that?
For the gun? Yeah, sure. And I'll actually, since I did a review on one, I'll actually take the one that I have a review on, and you can see me fixing that pair of scissors. But what I'm saying is, when I started thinking about this, the uses of this gun, you know, anything that's plastic can be reinforced. So it's really kind of a cool thing. So let me go find that link, and then I'll plug it in here. I have to go to another Chrome window.
Yeah, I guess the only other thing you could do is find a 3D printer that does vector printing. You know, so then you're reinforcing something along the lines of stress. You know.
Yeah. Let's see here.
Say, John, did you post up that other thing you had? Because if you got another one, I'll sit there and look at it and see what's going on. Because I mean, this is I'm 3D printing stuff, and the way it goes, and let's take a look.
I want to know why Dave Ackley is unknown tonight.
Oh.
He didn't put his name in?
Well, for some reason, it just doesn't want to take my name.
Okay.
Whereabouts unknown.
You've been unknown for a while.
In my view, it says you.
Well, that can't be right because that's what mine says.
Me too. Look at that. Probably if you don't put a name in, it just you become you.
Okay. There it is, where you can get it. And if you look at the reviews, you can see a video of me fixing my what do you call it? Scissors. But I'm pretty impressed, and like I say, I don't think I've ever heard anybody ever bring this type of thing up, and it makes so much sense. You know, we all do the little screw inserts, all right, and this is kind of like a screw insert, except you put a shaped wire into wherever you want to go. So it's
well, this doesn't work at all like I thought from your description that the 2 points of the staple went in first, but in point of fact, they go into the gun, and the back end of the staple goes in first.
Right, and the loop part goes in to the and then you just cut them flush. Now on a 3D print, I probably wouldn't sand it, but you know, if you were repairing a bumper, you probably would, you know, sand those points down. On what we could do is probably use a flush cutter, you know, and you could probably hit the end with a Dremel tool and not damage your 3D print. But
yeah, that's a brilliant idea to use that on for a 3D printer reinforcing. Doug, my neighbor's got one, and I worked with him on essentially fixing a broken plastic thing, kind of like your scissors handles, and it works great. It just like embeds itself in the plastic, and then you just flip off the pointy ends that are sticking out that were attached to the gun, and it's great.
Yeah, and the thing you got to remember, you know, because the first time I did it, you know, I was like push the button, stick it into the plastic, and then pull it out, and it will unclick. No. What you do is you stick it into the plastic and take the hand off the trigger, and let it cool down, and then you pull it off. But it works a lot better that way. So, but anyway, I just thought to myself, like I say, when you're doing 3D prints, if you've got a wall, you want to put a brace on the wall. That gives you a lot of strength. And if you have a straight wall, what you want to do is you want to break the straight wall up. You want to put a little dimple, or whatever you want to call it, a line of dimple, because that gives it structural strength, So there are a lot of tricks that you can do to make that third dimension stronger, but they're not going to be any better than stainless steel wire. That's going to be cool. Now there's another form of welding where you take like stainless steel screen, like screen mesh, and you take something that looks like a soldering gun with a flat tip, and you just do circles on the screen mesh, and you just slowly bury it into the plastic. But I think this would probably be more applicable for 3D printing. Unless, like, let's say you wanted to make two big parts. I mean, a big part, and your printer couldn't handle it. You can make smaller parts, fit them together. In those sort of prints, you usually don't want a straight line. You want it kind of curved around, and so they fit better. You have more periphery, and then you can just put these guys along it, and it ain't going to come apart. Anyway, I thought I'd share that insight, and you heard it here first. So.
I see where they've got the 100-watt job and the 150-watt job.
Well, the one I bought says it was 100 watts, but I have a watt meter, so they can't get around with that Chinese watt shit. It's a 50-watt gun.
Oh, seriously?
Yeah.
And what is the heating source? Is it a light bulb?
Electricity.
It's electricity. I think that I think it is. I never measured the voltage across the tips, okay? But I suspect it's like a little transformer in there.
Probably,
because it's pretty heavy.
Well, the reason I asked was because I was just looking at the web page, and one of the specs down the page says bulb wattage 100 watts.
Maybe something got lost in the translation.
All your base are belong to us. That's all I can say.
Yeah.
It's
Chinglish. I know that. It's like the 16500 battery, that 5,000 milliampere. No way. Even the premier battery companies probably can get 3,000. And 2600 is a golden cell, and they're saying they got 5,000. Just don't believe that stuff.
This looks pretty much like a modified welder soldering iron.
That's what I was thinking. Yeah.
Yeah, I agree with you. In fact, but I'm sure. I mean, I've watched YouTube videos. If you go out on YouTube, there's look at plastic welding. It's a big thing, because this is.
Well, Doug, if you go back and look at that web page, and go down below, scroll down to where it says videos.
Yeah.
And then go to the very next line. It says important information, bulb voltage 110 volts. Does it have a light on it?
No, it has an LED.
Well, what do you suppose bulb voltage 110 volts means?
I'm hoping they didn't bring out. I hope they didn't bring out these guys to 110 volts. I will tell you this: they don't get hot. these things, because the staple is such a high resistance
Scroll
compared.
down, it says output voltage 0 to 3 volts.
Okay, guys, you got me going here. I'll plug it in and measure the voltage.
Get out the voltmeter.
You guys see that?
Yep.
Yep.
Right below videos, important information, bulb voltage. That's why I wondered if the heating element was a bulb.
David,
No, I doubt it.
the staple itself is what gets hot, owing to the current flowing through it.
Yeah, it's just like a welder soldering iron.
That's what I assumed, so that's why I was puzzled by bulb voltage 110
Well, they
volts.
probably did their advertising using Google Translate.
Well, if you scroll about halfway down, it says the AC 100 volts, and below that it says input voltage AC 110 volts, output voltage 0.5 amps, but that's all right. Excuse me, input voltage 0.5 amps, output voltage 100 watts, output voltage 0 to 3 volts.
We can assume it's not ULE listed then, probably.
Probably not, no.
Harold, did you see the answer to the 131 in the comment section?
Yeah, it was 42 then.
It was 42.
Yeah.
It's 3.6 AC.
So
3.6 volts AC.
Yeah, 32,768, which is basically 2 to the 6 or something. Measurement unit over 250 degrees per second.
Yeah, it's just the conversion.
What, you guys find out what 131 is?
Mm-hmm.
Yeah.
Yeah, they're converting from the resolution of the sensor to degrees per second.
Yep.
So that's just something you get from the manufacturer, right?
Right.
Yep.
So Harold.
See, Harold?
If you look
being
at
being part of the club,
8.
you learn things, right?
Yeah.
Like what
I
does 131 mean?
And if you want further details, if you look on that on the page I sent out on exercise 8, they actually have code that you can click on there that is like high detailed math code. So you might look at it more.
Hey, maybe we could put that on our mugs. You can look at it and just say, "Oh yeah, 131." That's
Yeah, 131.
I know what that is. Yeah.
It's our 42.
That's right. DPRG.org 42.
Go make sure I get that, because my folks are going to be going, "What the hell?"
Yeah, you could throw a whole list of constants up there, what they are.
Yeah.
So, on the mug.
Avogadro's constant.
Yeah.
Very important to know.
I try to use that as much as I can, work it into casual conversation.
Yeah, a friend of mine went as an avocado, and he did it in a math way, because he had the avocados constant, which is guac over salsa kind of thing, going with the thing, and had the number in there. And geeks doing Halloween costumes. What can I say?
So Kareem, you've got me wondering, what's the stump the club question?
I think that was mine.
Wander some more. Muted.
Yeah, so
Kareem, your mic's off.
Still?
Or if you're talking.
Hello.
Oh,
Yep.
there you go.
All right. Um, I haven't really thought this through well enough, but I remember when we had this conversation a while back with Murray. And by the way, this is going to traipse on PID stuff, and I don't want to go down that rabbit hole. So but we can't ignore it because it's kind of related. So the question is, when you're doing PID control, and you want to sort of limit the amount of acceleration that you're going to have coming out of it, right?
Mhm.
And the answer here may vary, or the advice may vary depending on whether you're doing position control or you're doing speed control. But we're normally doing, like my teams are normally doing position control more than anything. But we're using a library. It's called Roadrunner, and it has motion profiles associated with it. And the motion profiles are sort of on the front end. So what they do is, if a path is just a sequence of points, right? And you could connect them either just as lines, or you could put splines through them or whatever. But that's just a set of positions on a field. Um, and then the next level up is to build something called a trajectory sequence, where you're adding timing information. And so if you add timing information, you can tell it how fast you want to go at any point in time. And you can sort of build in things like the maximum acceleration you want to see at any point in time, that kind of stuff. So that's a very planning oriented approach, right? You're figuring all this stuff on the front end before you send it as a goal for your PID to either set the speed or set the position at a certain time for your robot. And the good thing about it is that you can get all planny around it, and as a result, when your robot goes through those motions, it's going to be nice and smooth. And I think we sort of, if I recall, um, the discussion was, is that the kind of thing you want to do in the loop? You want to do it before, when you're requesting what the PID is going to do, or do you want to do it on the back end after the PID by um, sort of just limiting the acceleration that you see from one step to the next, right? Um, and so the fragility around this concept is that if something gets in your way and your robot is prevented from getting to a certain place in the motion profile by the time it's expecting to get there, then all of a sudden, and then it frees itself from that obstacle, then all of a sudden it's going to want to rush forward to catch up with where the motion profile is, right? And so it feels more to me like you should just um, do a little bit less planning on the front end, and I think David would probably go in this direction, and sort of build more of a behavior around just limiting your maximum acceleration. But the question that my open question is, what's the smart way to go about controlling it? Like, if you don't want to peel out your tires, right? You want your odometry to continuously work. What's the best way to go?
David will tell us.
Yeah.
So I can speak to what we did on the robot trucks at Lockheed and Outrider, because they had this exact issue of, and actually I'll expand on it in a couple in one direction. So what we did was the path was a series of points, as you say, and then each point had an associated speed, requested speed, and so you could potentially, if you were like generating a path and you said, I'd like it to travel at 5 meters per second along this path, you could it was perfectly valid to generate a path that began at the start point with velocity 0, and then point 1 had velocity 5 meters per second, and that would be your requested velocity. Then the control system would limit ramp up. So you had several parameters, including ramp, comfortable ramp speed, comfortable deceleration speed, and emergency deceleration speed. And normally you'd use the comfortable values, except if you had an obstacle, and then or certain like critical failures could cause it to use emergency deceleration, like it was coming to the end of the path and it hadn't received a smooth deceleration and was going to overrun the end of the path. There was certain conditions that could bring it, or an e-stop would use emergency deceleration. That was basically, I think we used 2.5 meters per second for comfortable acceleration and deceleration, and 5 meters per second for emergency deceleration. So to answer the first part of your question, there was not a goal to be at point X, Y at time T. Rather, the goal was to traverse a path at some speed, and it arrived at point X, Y whenever it arrived, based on the acceleration built into the ramp up and ramp down control loops. Now, to extend that thought a little further, and this has not been implemented at the time that I left Outrider, but you did have a problem where two trucks could be traversing the same segment of road, which was outside a warehouse, and they were going to, the definition of a collision was the two vehicles could be seen from their trajectories, from their observed trajectories and their observed positions and speeds, that they were going to occupy the same space at the same time. Then there was kind of like a real-time wraparound that would, so you're now moving into the multi-vehicle coordination realm, where you need to tell one of them to slow down or stop, so that the other one passes and hopefully traverses a different segment of path before it would reach. You de-conflict that two vehicles at the same point at the same time in the multi-vehicle planner section. Did that address the question you were asking?
Yeah, I guess my question was a little bit more like implementation wise. Do you do this inside the PID loop? Do you have a larger loop, or a larger control scheme around? We're actually using like a cascade of PID loops, right? Depending upon whether we want to control position or speed or whatever, or heading. And they're all like nested inside of each other. But yeah, the question, or you can even do this because you've already calculated a lot of this stuff in your PID routine, right? So you have things like acceleration figured out or very adjacent to your standard PID calculation. So I was sort of like wondering how you structure this.
Well, the another use case, a little different from the autonomous. Well, another use case was driving a pre-driven route, so recording the route that was driven, which I think is maybe a little more in the direction you're headed, and you would record the velocity that some human driver drove, and then, but again, you would record it as a series of XY points with a current velocity. Then when you'd replay them into the control loop, the velocity is an input, but it's treated as a requested velocity, so it's a set point. And then the set point is passed through a motion profile controller that in real time limits the ramp rate to the comfortable or emergency acceleration and deceleration values. So, you've got the set point, which can vary if it was a recorded path, but then that set point is modified according to the limits of the comfortable acceleration deceleration rate and then that's finally fed into the PID loop as a requested speed, based on what speed the acceleration would result in for the next time instant.
So you're basically calculating it ahead of time as a like a maximum speed or a requested speed, but you're profiling it sort of before you get to the PID loop stage, as opposed to on the back end, you could be monitoring what the PID loop spits out, because the PID loop is always going to try to get where you're asking it to go as fast as possible without ringing, basically, right? So, so if you want the PID loop to be able to perform in, in that way, well, so again,
Well, we were really doing
you
both.
could still do it on the back end, right? You could look at the PID output and you could say, oh, this is going to result in an acceleration beyond what I want, and you could damp it down there.
But so
you could do it front end
we,
or back
we were
end.
really doing both. So there was the front end planning part that's saying my desired speed at this point is X, and therefore there's an implied acceleration there. But then at the back, we're also at the back end, we were limiting the actual observed acceleration by limiting how much throttle was applied so that it didn't exceed the some manually applied limits on the acceleration.
So you also did it after the PID was calculated. Okay.
Yeah.
Cool.
And I think, Kareem, if you mentioned you have a bunch of loops, maybe cascaded or inner outer, and it strikes me that could it be like the when you have audio analog, maybe not just audio, but analog gain stages, you got to be careful in how you structure those, or else you might saturate one. You'd never know it if you only look at the outer parts of things. So it strikes me that part of your answer may be the standard engineering. It depends, because for example, another example it struck me was that, like, let's say the output of your PID loop is driving motors through a gearbox. Well, plastic gears won't be as robust as metal gears necessarily. So you might want to have a nice fast responding PID loop as tight as you can, subject to being torque within the constraints of not stripping out the plastic gears. But just by changing the plastic gears to the metal gears, or changing the load on the thing that it's moving around, the mass that it has to accelerate, you might very well change your decision of where to put the limiter. I don't know. I'm just thinking out loud. It's an abstract answer to an abstract question.
Yeah, it was a bit of an abstract question. I should have had like an actual example, but yeah.
That's all right. Give us
you're not trying to achieve
Anybody else?
You're not trying to achieve a certain XY position at a certain time, are you?
No. As soon as possible, given that we don't want to go beyond a certain acceleration that would cause us to lose odometry, basically. Yeah. But position is more important than speed.
Yeah.
By a long shot for this.
Yeah.
I think I would tend to go along with that. Basically, that as Carl said, that the PID controller is set up to be as efficient as possible to get you from where you are to what the set point is, whether that's an acceleration or a speed or a position. And then control the input to that. So, and now this might not necessarily apply because I know your robots tend to be heavier than the ones that that we use here in the group, and so there's different physics involved. But
like the backhoe, yay backhoe!
The PID controller actually has two inputs to it. Sometimes we forget that. We're just looking at the control input, but the other input is what's coming back from the real world, from your shaft encoders. So for example, if you're going down a hill, there's different physics driving the robot than if you're going up a hill or going on flat ground. And so just because you say, I want a velocity of X, doesn't mean you'll get a velocity of X. It may be considerably more than X if you're in certain situations. So I don't know if that helps any, but my tendency would be to say to isolate the PID controller, tweak it for the weight and the power of the motors, the torque and everything. And then if you need to do limits on that, you limit what you tell it. That might also be required you to look at its output. So maybe what I'm saying is you might have to do both. Both limit what you tell the PID controller to do and then actually read the output and see what it actually did. Do some correction there. I don't really have that experience. My heaviest robot is 25 pounds. I can easily pick it up and carry it around. Although I did find out that if you're halfway up a mountainside, a mile away from the road, when you break an axle, that's a lot of robot to carry down the mountain. But as I say, I know the physics is different when, basically when I tell the motors to slow down, it slows the robot down. It's not heavy enough that it has any momentum or inertia on its own. And that's a real different problem than the one you all have, I think.
Well,
Yeah, we're just not allowed to have the power budget to have that much dominance over the physics.
Which is probably just as well. I mean, giving the learning environment.
Sure. Right. Yes. It makes it a bit safer. Yeah. Absolutely.
Yeah, and General Motors, they, for the engine control loops, there was a thing called the Watt. It was the wide open throttle switch. So I don't think, Paul, you ever had to worry about that. It's like if you're trying to accelerate to pass, you just floor it and you would trip the Watt switch and, the engine would put out as much power as it possibly could, but
David,
probably
I think you did a better job of explaining the front and back end, particularly the back end limiting what's observed to happen than I tried to do. But yeah, I think you expressed it well.
Is that basically the same thing you were describing?
Yeah. You. I think you put into better words what I was trying to describe.
Smaller words, anyway.
Well, thanks. I appreciate it. While you guys are dispensing wisdom, I'll go ahead and make that plea. I put it in the comments, but basically we got a tournament 1 month from today, or 1 month and a couple days, December 10th, and would love to have this kind of level of expertise on our judging panels. So if you're interested, just drop me a line, and I'll be happy to get you guys registered for that.
Where is that, Kareem?
It's Townview High School, which is just south of downtown Dallas. It's off of 8th Street and 35.
South of downtown.
Yeah, like 2 minutes south of downtown Dallas. It's like right below.
Kareem, that's your magnet school, right?
That's correct. Yeah.
Yeah. Okay. Yeah, I've been there.
Is it the school for the talented and gifted?
That is one of the schools that's in there. There's actually 5 different schools. So
a school for the less talented and the less gifted.
Most of my students come either from TAG or from SEM, the Science and Engineering Magnet. That's the one I'm more associated with. But there's also a law magnet in there, and a business magnet, and a health magnet. So there's lots of different schools in there.
Reminds me of the Far Side with the little kid pushing on the door, and it's a magnet school, and it says pull, it's pushing to get in.
So what did you mean by robots made with the kinds of toys and gadgets that we couldn't even dream of when we were in high school?
Well, I had an Atari Actually, that was after high school. I mean, for me. I guess Trash 80s is what we had, what I had access to in high school, right? And these guys are they're building their robots with Android controllers and sophisticated H bridges and
IMUs.
IMUs and things like
Okay.
that. Yeah,
Yeah,
absolutely.
we were in high
We've
school.
got 3 IMUs on my leading team's robot right now.
When I was in high school, an IMU was only used in submarines, and they were a closet full of equipment.
Yeah.
You got
Probably still
you got kids doing GUI-driven convolutional neural networks, right?
Yep.
I
Yeah,
mean,
absolutely. Yeah. AI is figuring into this. It's crazy.
we were feeding paper tape into Altar 6800, right? I mean,
We're using Selectrix teletypes with paper tape readers and bunches.
exactly.
Think of what we would be doing now if we had access to that kind of stuff back then, right? So thinking of what they're going to be doing in 30 years or 40 years, it's just crazy. It's not even possible to imagine, probably. Anyhow, happy to have you guys join in with us.
This robot has been out hunting mice and rabbits. And he catches them from time to time, which really upsets my wife, but not my mother, who grew up on a farm. And and I may have repeated this, but I saw both of them respond in the same way when he had caught it was a lizard, a little gecko. And my wife said, "Oh, Star, what have you got? Oh, you got a little gecko." Okay. My mother said, "Oh, Star, what have you got? Oh, you got a little gecko."
I missed last week because I had this management meeting thing. We got some training. They're teaching us to stuff. And the weekend before that, the Halloween weekend, I was in Vegas. And yes, I got to attend a BattleBot show and VIP tickets and the whole lot. And I will tell you, as much as I look at them a little cross-eyed when they call them robots, they're just RC cars that beat the hell out of each other. But that whole experience was amazing. And watching a 150 to 200 pound robot being thrown 20 feet in the air in real life is a whole different experience than watching it on TV. It's pretty amazing. And the crashing, and then you get another experience because you're part of a TV show, so they're telling you when to stand up and when, okay, everybody on their feet, I need applause in 3, 2, 1, and everybody goes, yay, and all that kind of stuff. And you can bet I had my 3D glasses on, my LED glasses on in spectrum mode, so it was doing this number the entire time. I had lots of camera time. I don't know how much I'll make it to the air, but when I do, you will know about it. That is a promise. But this was an amazing event, and if you ever get a chance to go. The other thing that I thought was amazing that didn't air out yet, that just came out today, is the Ada box. If you're an Ada friend of the Ada box, the Ada Fruit Ada boxes, they will be back starting in the first quarter of 2023. They say they got all the parts for all 4 of the boxes for next year. So they didn't want to put out any boxes because they're afraid they wouldn't be getting it. They couldn't get in it. They couldn't fulfill everything. But now they got all the parts, all the things for all 4 of the boxes and the iterations they want to give. And so they'll start those things up next quarter. Which should be kind of fun. Which should be kind of real fun.
So is that a random kind of grab bag thing, or?
It is. It's, if you get online and look at the previous Ada boxes, the only Ada box that I've ever received I got it for Halloween a year ago. Yeah, and it was the 3D glass. It was the circuit board glasses with an LED matrix across it, and a Bluetooth control Ada Arduino form factor that fits on the side of the glasses. that you're able to take with your phone, change the color, print messages all across of it, or program it in Python or C++ to do all kinds of things. And it's got an IMU on it as well, so you can shake your head around and it does things, and it does all the animations and stuff you can do. And that was a fairly random thing that they give you. But normally you can make a guess at what they're about to send you, because look at the Adafruit things. Hey, we were just playing with this and we were thinking this was cool. And if you watch that fairly closely, you'll see that what they're doing is they're giving you previews about what you're going to get in the next box. And so the last time they were actually doing those things, they were doing floppy controllers to plug in to make them up to your like feather wings and various different things like that. And I don't know what the actual use is, but what the hell? There's something. Sometimes you get LED OLEDs. Sometimes you get other bits and pieces, and they give you a complete learning thing to put all the stuff together on it. And it's $60 once a quarter. You got to get signed up, and they don't bill you till it ships. So it's not. And knowing what on the one box I got, if I would have had to buy all the parts to do all the things that I needed to do, because you can buy them right now separately, I probably would have spent probably in the $70-$80 range for the $60 box. So you get a little discount off. Yeah. Oh, and yeah, see, I was a VIP. That kind of thing. And I tried to get in the behind the scenes of it, but they could not accommodate me on the very, very busy Saturday I was there, because I got signed up as an honorary member of Vegas Combat Robotics, and that would have been the robot named Switchback, if you know anything about that, because I've got to in a little bit with the Vegas makerspace, and they do a lot of work with those folks, a lot of relationships with them. I'm going to have to do something different on that, aren't I? I think I might have an idea. Yeah. Anyway, I had lots of fun. Went and saw Blue Man Group. The crew I'm talking to, looking at right now, you dig every bit of Blue Man Group, guaranteed. For instance, one of the times as they were on, they did a whole bunch of fun things. But one of the things I thought was really neat, and I'm like, dude, I could do that. They got a bunch of bass drums, or very like your furthest away tom in your drum in your trap set, that sort of thing. And they had them turned on their side and pointed at different angles. And then what they ended up doing is they ended up blowing up fog through them. And then they would bang on the drums, and these smoke rings would come out of all these drums, and they were shooting smoke rings across the auditorium. It was pretty cool, man. It was really pretty cool. And they got lasers and neon and other things and goofiness going on and all those sorts of things. Had a great time out there. Great time. Oh, and one other thing, I'm going to send it out to the list, the DPRG list. Improving is helping sponsor Code Launch, which is November the 16th. Yeah, the 16th at Gillies. So if you're local to us, I'll send you out a link that'll get you a free ticket. Come see the Code Launch. It's really, really good. It's really, really good. Take care, Pat.
So the next time we meet is Saturday?
Saturday.
And Doug, I sent you an email, just said address, question mark?
Yep, I got it.
All right.
I sent you one too.
See y'all Saturday.
All right.
Yeah. All right.
Everybody heading out?
I think so.
Okay.
I guess.
Take care, guys. Good night.
Good night, guys.
Carl, do we need to talk anything later about Saturday?
Actually, I was going to ask. I'm sorry. I just got back from my flights, and I'm just not thinking totally wiped. So, are there any open issues with like Doug, you had mentioned earlier? There'd be food, but is that stuff all arranged, or do we need to divvy up tasks to?
That part I didn't address. I
We
basically
probably
said
need to
no.
talk to Steve and
Right.
have a meeting with him and get that. And we got to show up kind of early, and I got to make sure we have some paint to draw the circles that's not going to kill his grass or or anything like that.
Where's Trish and those? Have you stopped the recording?
The recording is still going on, but I can stop it. Okay, give me a second. Okay, recording